Okay, so where have we got to so far? Well, we've seen our different flavors of t-tests. We've also seen a bunch of other things. So we've been looking at means, we've been looking at standard deviations, we've had this reference to samples versus the population, and really made some progress in seeing the three specific flavors of t-tests that are out there. Now, what are some things that are important to remember here? Okay, so with our tests, we're using our tests to say something about population values. We're not interested in the samples as such, but we're interested in the underlying populations that we're making statements about. We've seen that the t-tests come in a number of flavors, or that there's a family of t-tests. So what are the three flavors of t-tests that we get to look at? We have the single sample t-test. So this is really for someone, for someone like me, this is where we have an environmental standard and we're monitoring a site to compare what's happening. So it might be monitoring discharge at a wastewater treatment plant, or monitoring environmental conditions, and we have a set standard. A more general application is really the two sample t-test, and we're comparing two different samples. So that probably has many more general applications than just some of the ones that I tend to use. And then we have the paired t-test, which is a specific type of two sample test where we have some structural relationship between the two samples. I usually refer to it as a before and after test, but it doesn't have to be before and after. It could be some general thing, like the pairs might be, maybe in a social science thing I can think of as couples. You're measuring happiness or something, and you have people in couples, so there's a structural link between males and females in that sense, or something. It doesn't just have to be before and after. In the sciences, it tends to be before and after, and I think most of the examples that I've ever come up with are of that flavor, but it's certainly more general than that. So we've got these three flavors of t-tests. This is our core sort of topic that we're going to be covering. We're talking about energy and pollution, and so we're wondering about why or how are these sort of tests that we're learning about applicable to circumstances that might fit within this theme. So one of the things that we could talk about is household energy consumption. So with electricity consumption, okay, it depends a little bit on whether you've got gas connected or not, but in this data set, all of the households that are being compared are all on an electricity system. So it's not that some of the energy is being generated via gas, and in particular gas can be used for water heating and cooking applications. So we're looking at that, and Australia looks like we're up towards the end of this. You can see that also what stands out, electricity consumption. The rich countries are towards the top of that table, and that's just a representative. Okay, so it's picked out, high income countries. There's a whole lot of countries. It's just trying to give you a selection of, and the colors, representing a selection along the way of the different levels of energy use. Where does the energy use take place? Well, if we look at it in Australian households, most of the energy is for heating and cooling. So these are air conditioners and various heating applications, whether that's reverse cycle air conditioning or direct heating applications. Very big chunk is then around water heating, and then lots of other things that are picking that up. In the other appliances is picking up audio visual stuff. Those big TVs tend to churn through a fair amount of electricity. So which appliances are really driving this? So I'm saying here, within the appliance space, in your total energy consumption, it is heating and cooling driving that, audio visual, and really you could almost delete the audio part of that. It's the visual. So big screen TVs are relatively energy intensive, refrigeration, lighting, and so on as we go down the list. So we're interested in this. Why are we interested in this? We might be interested in the broader policy of climate change and understanding what's happening with the energy consumption space. And there are a whole range of questions that you might want to look at. Are there changes through times? There's certainly energy consumption changes through your life cycle. rural households different to urban households? How is weather changes and the temperature impacting energy use, rich versus poor, and that might be the rich can have more energy consuming items, but poorer households might have less good insulation in the house and actually use more energy. So there's all sorts of different dynamics that we might want to look at. So a whole heap of interesting questions that we might want to ask about energy use. Because we want to ask some questions, we would go out and collect some data, and you could see we might have sampled energy consumption. We would have some information on the state and a whole bunch of other characteristics. So our rows would be giving us each case, and our columns would be giving us our variables. So we would go out and collect this data. Now, something that we may want to talk about is something about, how does WA perform relative to the national average? So in that case, because we would be comparing WA to some known national average, we would be using a single sample t-test. And we've gone through all our data, and we know that we use the national average standard for energy consumption is 16.5 kilojoules per day. All right, so if we want to test WA, set up the null. The null is that daily energy use in WA is equal to the national average, which is 16.5 kilojoules. Daily energy use is not equal to 16.5 is the alternate. Alpha 0.05, so we use that 0.05 when we apply our p-value decision rule. We're going to then say something about what our test result is. First step, we create a plot. So for this one, I've created a histogram. And what have we got sitting in here? We've got the sample mean, 20.4. So we know our sample data is showing WA higher than the national average, and we're testing against 16.5. So we know that we've got our sample is above the test value, but we want to understand, is that difference we observe just due to sampling variation, or is that a true difference? So with our plot, it's not clear to me from that plot which way to think about this. We then implement our formal test. So you can see with, and I've called it here the energy 1 data, apply the t-test to the variable WA1, because that's the way it's indexed in the data set, and test it against a mean of 16.5. P-value less than 0.05, so we reject the null. So we know that our sample mean is 20.4. So by looking at the sample mean, we know that, that's actually above our 16.5. So we know that WA electricity consumption is above the national average. There's something structural about us being above that. So we have found something that we would say is a statistically significant difference. Of course, that is just a starting point for our discussion. Is that meaningful, that difference that we've discovered? Is it practically important? Is the sample representative? We might have to think about this. Did we have a big enough sample to appeal to the central limit theorem? All of those sorts of things are the things that we would then flesh it out. So we conduct this statistical test only because we're interested in then thinking about different questions, answering something that's useful, or trying to inform policy, trying to do something. And that's an opportune time for a break.